Hello, and welcome back for our next panel, Decarbonizing Heavy Transport. For this panel, we are welcoming three experts. First, we have Alejandra Fabian. Alejandra is the Power Infrastructure Manager at Milence. With a strong technical background in power electronics and energy solutions, she specializes in the electrification of long-haul trucking and the infrastructure required for charging sites. Alejandra's experience spans from e-mobility to the grid integration of renewable energy sources like solar and wind and real-time simulations of new systems. And next we have Dr. Rowe, Director of the Heavy Duty Vehicles Program and Deputy Managing Director for the International Council on Clean Transportation, or the ICCT. His work is dedicated to minimizing the climate and air quality impacts of transportation by advancing both conventional and electric powertrain technologies. Before joining the ICCT, Felipe gained experience in industry and academia, focusing on pollutant formation in combustion engines and the role of emission control systems. And then finally, we have John Buckoke. John is the key account manager at Ekoenergetyka, bringing over 15 years of experience in driving revenue growth through customer success. He brings extensive experience in developing strategic partnerships and expanding markets. With 8 years of experience as an EV driver, John leverages his practical knowledge to provide customer focused DC charging solutions and fosters long term relationships with EV charging infrastructure partners. So, thank you to all three of you for joining me this afternoon. First, we will actually start with Felipe. How do you define heavy duty vehicles or heavy road transport for any of our listeners who might not know the actual definition of what we're talking about?
Right. I think the definition is quite intuitive, right? So all of us have been on a highway in a car and we've seen this beast of the road driving next to us. They can be intimidating. But they are the trucks that transport all the goods that we consume, that the industry needs for their productions, and that are the backbone of the economy. So, in technical terms, a heavy duty vehicle is something that weighs more than 3.5 tons of gross vehicle weight. So everything from those heavy vans that you can use for, I don't know, like moving furniture in a city, all the way up to 40 plus tons, right? And even 60, 80 tons in some European countries that are the tractor trailers that carry heavy goods over long distances.
Okay. And I think we've lost John just for the moment. So, Alejandra, in your opinion, is electrification the obvious path for decarbonizing heavy transport, or do you think that e-fuels or something similar is also the right avenue?
Well, today I think electricity is the sector that makes most sense when it comes to economic and energy efficiency. And we start to see that in the market uptake of this basically sale of heavy duty vehicles. So already 95% of them are electric motor on board. And well, today we see the first generation of this technology, right, which only gives us, I would say, an outlook that there is still a lot of technology improvements to be done, which will be focused on making the whole technology more efficient, and therefore the cost of this solution, I say, more competitive to reach the TCO parity with diesel engines. When it comes to alternative fuels, well, I think there is potential. It's still to be seen which niche applications could benefit from this, but I think at the end the market will decide which are these.
Okay, and Felipe, in your opinion, why has the electrification of heavy road transport lagged so far behind lightweight vehicles thus far?
So the quick answer is because of regulation. So we've had CO2 standards for light duty vehicles since many years. And then these have been requiring the efficiency improvements or reductions in CO2 emissions at the new vehicle fleet level for manufacturers. This is something relatively new for trucks, right? So the first round of CO2 standards that were adopted in the European Union um, was in 2019 officially, right? And since then is that we see a lot of activity from the manufacturer side to deploy and to develop and deploy these type of electric trucks that now we're starting to see in larger volumes, right? So what we were lacking is a bit of that regulatory push to make this happen, right? So that is the number one difference that we've had between light duty and heavy duty vehicles. The second reason is that even though they share a common technology, the batteries are very similar, the motors are very similar, there is a different set of challenges, right? And we're here talking in this great for days. And this is about the infrastructure. And that's why we have Alejandra here from Milence, because this is the next challenge that we need to tackle, right? So you're not going to see trucks parked on the curbway in cities just charging in front of where the driver lives, right? They need to go to the depots, they need to go to the public sites to charge. And that deployment is going to take some time. So understanding these market dynamics, these industrial dynamics, provides a reason on why this has been, I wouldn't say lagging, right? But it's just having a different starting point. But I would anticipate that now with the regulation that we have in place, that is much more ambitious than the one that we had a few years ago, with the infrastructure deployment that is forecasted under the AFIR. We're going to talk about the alternative fuel infrastructure regulation today, I hope. This is going to take off very rapidly. Manufacturers are ready for this.
And actually, going off of that, and this is a question then to both of you, why is it so important to decarbonize heavy road transport, especially when you go on the highway, you do see much more lightweight vehicles than you do the heavy duty ones. So why is it still important to decarbonize the heavy ones?
Maybe I can start here because this is exactly the type of analysis that the ICCT does, right? So we conduct this not only for Europe but also at the global level, given that we're an international organization. So allow me to frame it first, right? So climate change, global CO2 emissions. We're talking about 40 gigatons, million tons of CO2 that are emitted every year, right? 40 billion tons of CO2. Out of those 40 billion tons of CO2 across the economy, right, about one third is for transport, right? That is shipping, aviation, light duty, and heavy duty vehicles, right? So we're already kind of like at 12 gigatons of CO2, 12 billion tons. And then if you look at the contribution of heavy duty vehicles, right, we're looking at about 30% of that as well, right? So you do the math, right? 3.5 gigatons of CO2. And then we're looking at the emissions of India, right? So heavy duty vehicles and the full emissions of India across all the economic sectors are comparable, right? And I'm picking India deliberately because as we see that GDP growth takes off, right? Economic development takes off, the freight system is closely connected to it, right? So we could expect that without a move towards electrification, without a move towards decarbonization, these emissions are going to continue increasing at the same pace that many of these economies will develop in the coming years. So addressing the emissions from trucking and road freight is imperative.
Alejandra, anything to add?
I have to say that Felipe did all the good talk here. I was going in the same direction. I mean, emissions. I think it's the climate change is, I say, is the main driving force for this, and I think we need to tackle the major producers, and transportation is one of the biggest one, as Felipe
Yeah.
already all the statistics are forward.
Well, then maybe because I think John is gone. So
Okay.
I will give you the next question.
Yeah.
What are the challenges of extending the range of electric trucks while also overcoming design and product challenges such as the weight, the space, the aesthetics, and how would this also differ from the lightweight vehicles?
Well, let's. There's a lot of different angles from this one. When we look into the light weight vehicles, well, they have different requirements when it comes to range, right? So that's why we have seen an easier or faster adoption today with lightweight vehicles. When it comes to electric trucks, there needs to be a balance, right, on the design of the payload that needs to be transported by the truck itself, and the battery pack that needs to, fulfill the energy requirements for the distance to be traveled. Um, so this, I think, was one of the main challenges to find the sweet spot and the design of the technology to meet this. And I see that John is back, so not sure if he wants to add something to this question.
Could you repeat the question for me, please?
Yes. So, what are the challenges of extending the range of electric trucks while also overcoming the design and product challenges such as weight, space, aesthetics, and how do these differ from a lightweight vehicle?
Could I answer it from a different perspective, please?
Sure.
Do we need to extend the range, or do we need to become better at logistics? Do we need to think about traction and haulage capacity as common entities controlled by an AI scheduler? Will that then limit the range needed of the truck? Do we need a long range truck if we can improve the scheduling?
Would the question be which is an easier or a faster problem to solve, the logistics or the vehicle? Oh, no.
Nope, we don't.
No, it seems that okay. There you go. So we lost him, but I think it's an interesting angle, right? So I think whenever you talk about road freight, you don't talk about it in isolation. So it's part of a freight system that includes rail, includes waterways, includes aviation and shipping, right? And
Mhm.
where possible, we should be looking at first increasing the efficiency of this freight system, right? Right now, what we see in Europe is that many of the trucks that you see on the highway are actually empty or not fully loaded, right? So I think there is something that can be leveraged there to first make the best utilization of that asset that already exists and it's already polluting, right? A truck will emit CO2 emissions regardless whether it is fully loaded or not. So making best use of that capacity is something that we can still leverage. And doing a modal shift from roads to rail, it's the other holy grail of multimodal transportation, but this is something that is very difficult, right? So the rail system in Europe in particular, it's low carbon, yes, but it has its challenges in terms of capacity, cross-border operation, just-in-time delivery for the logistics. So even though this should be always something that we aim to do, the reality is that trucks offer a more flexible freight system, and are going to continue to see those in increasing numbers over the year. And that's a reality that we have to live with and plan for in our regulation and in our electricity systems when they get fully electrified.
Okay. Alejandra, do you have anything to add with that?
Not from the perspective of Felipe. I was going more from a technology perspective,
Mhm.
addressing the challenges to basically extend the range of trucks. So, as I mentioned, is simply designing the battery pack to be able to carry the load that a truck. So, finding the sweet spot between the battery pack size and the load that the truck needs to be designed for. When it comes to bigger batteries, it comes with a space. It comes with a higher needs on cooling of the battery pack. Comes with a higher charging capacity needs. So it basically everything is over dimension from what we see today in technology, and I think that's one of the challenges we see with the OEMs. Right, they need to come up with the right efficient design for the truck to make it happen.
And actually, going off that, Alejandra, can you speak about either the challenges or the benefits of megawatt charging?
Oh, that's my favorite topic. So in Milence, in Milence, we really focus on megawatt charging. We are a CPO that will be on road and also in specific logistic hubs. But megawatt charging, we see it as like the enabling technology for long haul transportation, because basically the benefit that it brings is that it offers better charging times from what we see today in the charging technology that you find out there today. So the goal is that we can charge a truck in 30 minutes, basically, which in today's technology is not really possible. And it also comes with some benefits around reliability, which is key for this segment, right? We are serving the logistics backbone of our society, so we need to bring reliability in their operations. So megawatt charging is designed for heavy duty. The communication protocol between the charger and the truck is Ethernet based. So let's say that it has higher noise immunity and low latency. Today, we see with the EV passenger market, a lot of the problems operationally has to do with this, point of communication between the truck and the charger. Also, let's say the connector has lower mechanical tolerances, which means that there is less problems, or we expect to have less problems during the plug-in time, which is a common problem also for CCS connectors. So lots of benefits with this new technology that we can see.
Were there any challenges, or are there any challenges, though, that
Yeah,
OEM should be aware of?
definitely. So I think the challenges that we see today are mainly because it's a new technology that we see in the market. So the challenges, let's say from a charger manufacturer perspective, it's more about putting out a product that which standard is not official yet. So there's some risk. Some risks for that. And also delivering the 1 megawatt at dispenser level, right? That's the real development push that we see today with manufacturers. From Milence perspective, as a charging point of operator and infrastructure owner, so we see that today's charging technology, it has a big footprint demand. So we are already struggling to find parking place for trucks. So if we want to deploy several megawatt chargers in a single place, it will require too much footprint with the technology that it's available today. So we're asking charger manufacturers to work on having higher power density in the charging pack, so that we can make this basically scalable business for us. Installation challenges as well come with this. So every megawatt charger, as the name says, it's designed for 1 megawatt or more in power. Lots of the charger manufacturers or chargers that we see today are connected with 400 volts AC. So that's like, let's say, the lowest voltage that we can see in industrial applications. So when it comes to the power that you need to transport at that voltage, is the cables or how do you connect this, it becomes quite a headache. Let's say from an installation perspective. So we also need to make this technology more scalable overall. And so the scalability, let's say, will be the main challenges here. How can we design technology that is scalable from a business perspective, taking in consideration the technical aspects of this?
Yeah.
Yeah.
That actually kind of leads me into a question I did have for John. John, what other advancements do you believe are needed to make electric fleets more viable? For example, mapping and location services or smart charging, so on?
I think smart charging is important, the product that you supply.
Mhm.
the ability to access cheaper electricity, I think is very important, because logistics industry is heavily optimized on price to get people and goods from A to B at the lowest possible cost at the most reliable. So I think definitely being able to access cheaper tariffs, cheaper prices is very important, and through utilizing smart grids, basically. Localized pricing on grids, for example, is one such area where you can deliver much lower pricing.
Okay. And are there any regulatory or commercial barriers uh, that also make the widespread use of electric heavy road transport more challenging? This is still to you, John.
All right, yeah. So the kind of the way that the UK power grid is regulated makes it currently impossible for localized pricing. But also, it's the way the half hour ahead and day ahead markets are structured in the power market. You may not know that the UK, the way power is auctioned in the UK, that when the market closes, the price settles on the highest bidder. So even if there is cheap, affordable, renewable electricity is available, if someone comes in at the last minute on the auction with a dirty diesel peaker at a high price, everybody gets that price. So that's one of the things that would be keeping the electricity price high. Renewables are cheaper, provide cheaper power, but so that's one big issue with power pricing in the UK, is the way that the auction is structured, which keeps the price high effectively.
Okay. And Felipe and Alejandra, actually, the same question to both of you in the countries where you two are located. Are there any regulatory or commercial barriers that are making the widespread adoption more challenging?
Right. So maybe I can try to build upon John's point, right? Because this being, like the panel focusing on the integration of electric trucks into the energy system, um, these price signals and price benefit, right? Reduction of cost for fleets of electric trucks is something that is fundamental, right? So we need to see that in the regulatory structure and regulatory frameworks of many more European countries, right? Time of use tariffs is something that will unlock economic benefits, but it will also unlock grid capacity that right now it's in short supply, right? So the challenges that we see is that framework is not very well established right now. So more work needs to be done on that, right? Just to unlock existing grid capacity and to provide the economic benefit associated with that flexibility, of course, through price signaling. But if we go beyond that, right, at some point, the existing grid capacity, be with smart charging, with bidirectional charging, for example, will simply not be enough, right? And the grid will need to be reinforced and will need to be expanded, right? And navigating through those permitting processes that right now take very long, right, are very bureaucratic processes that differ across all of the European Union, right? So you will have something in a little distribution system operator in Germany, they will have one process, and then you go to France where they have this one massive energy company, right? And eddies, then it would be completely different, right? And then having not only companies which are rather large, like Milence, navigate this, but also fleet operators, right, who are in the business of moving freight, right? Their business is not to become an energy supplier or energy provider, right? So this is not what their core expertise is, nor it should be, right? So just simplifying this is very important. And the last point is to be able to think ahead, right? Because right now we're looking at a volume of electric trucks of about, I don't know, 10,000 trucks per year, right? Which is, give or take, 2, 3% of the market.
Mhm.
Um, when we look at 2040, right, and that CO2 reduction target of 90% kicks in, we're going to see hundreds of thousands of electric trucks being added to the market every year. And the grid will need to be expanded, right? And to achieve that grid reinforcement and expansion ahead of the demand, right, we need to start negotiating now. We need to start updating our regulatory frameworks to enable that anticipatory investment that right now it's very difficult to get, right? There is this tension at the member state level between the national regulatory authorities responsible for allowing these grid expansions trying to keep costs down, right? So only build as much as needed for what we have today with the needs that we will have in the future and the distribution and transmission system operators would like to have to satisfy that demand, right? So finding a way of navigating that tension, right, and enabling and creating a robust framework for anticipatory investments is, necessary and very urgent.
Yeah. Maybe adding on to Felipe's comments, we live this, let's say, pain every day in Milence. We are operating in 14 countries in Europe, and yeah, grid permitting is one of the main pain points for us. So we need regulation to make all this process more transparent and streamlined across Europe in terms of grid permitting. Otherwise, basically, the whole process can take months to just get, let's say, a confirmation that there is grid capacity. And then we look into countries like Netherlands, where simply there is no grid congestion is everywhere, right? All grid permitting is just on hold for years now. So we also need to have, let's say, clearer frameworks, as Felipe mentions, when it comes to how to collaborate with DSOs or any other stakeholders to, let's say, have creative ways to exploit flexibility in the grid. And obviously that needs to be balanced in how this market works, because let's say at the end road transport requires they're working on a schedule, right? Flexibility there, it's to be seen how it's affected with either let's say the time of use tariffs, but also needs to fit on what are their needs in their business. So we need to find the balance there, and the right detailed tools to find the sweet spot on how to make the efficient use of the, let's say, the infrastructure that we are providing.
And actually, John, did you raise your hand?
I think
I thought I saw
one
it.
of the other things that interests me about coming back to the smart grid technology is really understanding there are a lot of licensed power connections in the grid, but how are they utilized? Is there a lot of hidden capacity in the grid that simply is licensed to someone, but they don't use it? Or they use it dynamically. So if you use smart grid technology, which is reading loads on smart meters, which then tell the charging facility what power is actually available in real time versus what's theoretically available on paper. That can be a way of increasing capacity for a charging facility, which then is smart. So it doesn't try and pull power that's not available. It pulls power available on the box. And that's, I don't think, is done, is it? I think the key is making grid smarter, and treating the power grid. The power grid is a physics model. It's not a competitive market. The power grid doesn't match supply and demand; it blacks out. So, and this I think is one of the challenges. And I think the problem is actually regulation. We want more regulation. We want less regulation and more physics. More actual machines doing the talking, not politicians doing the talking. There was a fascinating image I saw on X, and it was a picture of Elon Musk watching the Starship launch, and they were all gathered around watching, and there was a picture of the European politicians gathered around a laptop writing legislation. That legislation's not helping us. We're probably held back by legislation. We need to look at the grid as a physics model and then allow it some level of autonomy to manage itself, to make sure that every watt of capacity that's available is actually available, rather than having a theoretical environment. That would be my take on it.
Nice. We have 2 audience questions, so I just want to make sure that we get to them. Alejandra, this first one might be for you.
Okay.
Can an EV truck last as long as a diesel truck? How long does the battery last before the end of life, and it needs a replacement?
Well, I'm not an OEM, let me say that, but I can only imagine that right now all the trucks that we are working on need to be as competitive as the diesel, let's say, expected lifetime of a diesel truck. So otherwise, there would not be a competitive advantage to jump over that, right? So I think standard is 15 years, if I correct? Maybe Felipe, John, you know about that? 15 years is the standard lifetime we expect in a truck.
So this depends on the number of cycles, right? So typically, batteries. We're talking about the battery, right? So I think
I'm talking in general lifetime of a truck, right? Because if we jump into how long a battery lives in cycles, then I think it's
correct. So a truck can live to be 15 years at least, right? So
yeah,
the average age of trucks in Europe is about like 14 years. It depends on how you measure it, and this is the average, right? So there's trucks that are significantly older than that, and trucks that are much newer. So I think they need to be designed to be, like at least 2 decades. So the question with electric trucks is then, what about the battery, right? So, and I think we've seen a lot of improvement on that.
yeah,
So in terms of, the calendar life, how long the battery lasts, and it degrades just because of time and the chemical reactions happening there. And the cycle life, which is how quickly it degrades because you charge it and discharge it, right? And I think the goal that we're seeing now from OEMs, battery manufacturers, and so on, is to eventually reach kind of like 10,000 cycles, right? And 10,000 cycles would be sufficient for the life of a truck, right? This wouldn't be, like think about cycles, like you cycle the battery in a day for a truck. So this would be definitely sufficient. So I don't anticipate any limitation from that perspective in the future, right? But right now, like experience might prove a little bit different, right? So if we look 5 years ago, there were a few electric trucks in the market, mostly retrofitted, right? So these small companies that just took the engine out and put a battery and so on. And if you look at those, probably the batteries degrade quickly, right? They don't have the full lifetime. But now, once we move to serious production, battery manufacturers get better. We pick the right chemistries, right? For example, LFP, getting very technical, LFP tends to have better life than NMC, and we see Daimler, for example, moving towards LFP batteries. So all of this is going to play in favor of lifetime being comparable for both diesel and electric trucks.
And I think, John, were you waving your hand a bit ago? Yeah.
Again, it's about a revenue model for me. So it's not so much of how long the battery lasts, but how much money the truck can earn. And there's also the issue of DC charging. If you put more current and voltage into a battery, over time it will have a greater impact. It will stress the battery chemistry more. And the UK can't answer the question like how long will the battery last. It's how the truck is. So there are some tracking units in the UK double shift, so they're running 80 hours a day. And so the truck may struggle, a diesel truck it's struggled for the last 6 years because it's done so many kilometres, because it's been double shifted, it's done so many hours.
I think, John, I'm so sorry. I don't know about Alejandra and Felipe, but the sound's not coming through very well
No,
on
not
our.
really. I'm making an effort trying to follow, but it's really challenging.
Yeah, I
Yeah.
followed before. But it's cutting you in and out too much, unfortunately.
Okay.
Let me though. I just because I know we're getting towards the end of the panel, and I just don't want to miss some of these other audience questions. This other is, how is the total cost of ownership of EV trucks compared to diesel, looking at the CAPEX and the OPEX, OPEX?
This is something that we do almost on a daily basis, right? So we have been developing TCO models, and um, the answer nobody likes is it depends, right? It depends on
Yeah.
where, like where is the truck located, what use case does it serve, what energy contract do you have, how do you charge the truck, and so on. But if we look at some average use case, right, in an average European country, the capex is going to look much higher for the electric truck, right? So let's say about 2 times as much, right? And this has been dropping significantly. It used to be about 3 times when we first started tracking this. Now we model this with about 2 times the price of a diesel truck. And on the OPEX is significantly more advantageous for electric trucks, right? So the cost of electricity, and I think Milence is going for 39 cents per kilowatt hour, which is fantastic, right? This is the good ballpark to achieve kind of like that cost parity with diesel, but you can go even lower than that, right? If you do depot charging, if you have photovoltaics generation at your depot and so on, you can see 10 cents per kilowatt hour, right? And once you have those conditions, the more you drive, the more you save, the better the TCO is, right? So right now, it's a similar answer as I gave before. Right now, if we look at it, there is going to be some use cases where the TCO for battery electric trucks might be lower right now, but not for all of them. But as we continue making progress on getting the batteries cheaper, the vehicles cheaper, and the energy costs lower, battery electric trucks are going to come ahead than diesel in any situation, especially as we continue introducing carbon pricing, right? The emissions trading system too, now including transport, the Eurovignette regulation that has a CO2 component when you go on the road, right? So the road tolls that you have to pay now have a CO2 component, or should have, in most European countries, right? So that will make diesel a bit more expensive. It will make battery electric a bit cheaper, and the TCO parity will for sure come by the end of this decade for most of the use cases.
Nice. And actually, just to end the panel, I have one last question for all of you. How do you envision the future landscape of in-route charging versus destination charging? Maybe start with Alejandra.
Yes. Well, I think both are essential for the success of this segment, indeed. In route charging, what Milence business offering is an enabler for long haul transport. It's just needed. From a destination charging perspective, I believe that we need to work on, making the use of infrastructure, let's say, utilize it better, as John had mentioned already, right? It's not just from the grid perspective, but it's like the total cost of investment for this type of infrastructure is quite big. And a lot of fleet owners cannot afford this, or simply is not viable for their business, right? So we need to find business cases where basically we can maximize the utilization of the infrastructure, making it public or semi-public, depending, on every use case. That's it.
Maybe I would add that to try to add a bit more flavor, right? Because I think destination and en route are two very broad categories, right? In destination, you could have privately owned depot charging, semi-private at logistics centers, and there you have two different, like business models and so on. So that is definitely going to play a key role, and this is the sort of infrastructure that we have today supplying these, I don't know, 20,000, give or take, electric trucks that are on the roads today. When it's about public charging infrastructure, right, we will see that en route typical megawatt charging of 30 minutes for these mandated truck stops that the drivers need to take. But we'll also see a lot of overnight public charging, right? Because the road freight system in Europe relies on hundreds of thousands of trucks that are just waiting there for the spot market, to react to the demand, and they don't go back to their depots, right? Every other day, right? They have to go back. These are the cabotage rules that are set at the European Union, every week, every 2 weeks, right? This is something that is being kind of like discussed right now to relax those cabotage rules, but they have to go back to their depot at some point, but not for most of their use case. So they will have to rely on public overnight charging, right? So the way that we see it, and when we do our analysis, that most of the charging needs will be served by this type of overnight charging, whether it is depot or public overnight, that will serve most of the energy needs. And then the megawatt charging is going to be the enabler for these longer routes that really need to go over 500 kilometers per day. So it's going to be a complementary system, of course.
And then, John, I don't know how your sound is doing now. Do you have a last thought to add before we close out?
Hear me? I think it depends on the truck.
No.
Trucks, it's interesting that how much time trucks spend stationary loading and unloading. And so I think there's a lot of opportunity for charging at depot, at destination, which will mean the truck.
Yeah.
That's it.
So sorry, John, but thank you so much for joining. Thank you, Alejandra, Felipe, as well. As a pretty avid car enthusiast, I found this discussion fascinating. So thanks so much.